This video is brought to you by Fractal and the Meshify 2 RGB. Because the Meshify 2, I mean, it's basic black. It's Ford Model T black. There's nothing wrong with that, right? Well, it turns out there's some people that really live and die by the RGB. This is for you. Now, the Meshify 2 is a full Meshify, which means that it comes with a lot of accessories and has the removable top, unlike the Meshify Lite with the top cartridge dust filter. And a plurality, nay I say a quartet of internal fans. 3 in the front, 1 in the rear, and yes, they're all RGB. Inside you got all the build options you know and love. At the rear we've got extra cable management accessories, and even a cable hider door that hides your sins. And not only that, they give you even yet more accessories. 4 3.5-inch / 2.5-inch drive bays that you can stack up here at the front if you want. You can even use them, elsewhere in the case. Get a lot of options. Check out our Meshify 2 review. You can learn more about the Meshify 2 case, but this is with RGB. Thanks Fractal for sponsoring this video. Be sure to check out the link in the description below if you want to learn more about this case and maybe use it as a platform for your next build. Well, hello and welcome back. All right, this is our home server series for the non-fire breathing, super fancy, crazy, epic, whatever build. Now, in the series we've covered up till now, we have talked a little bit about repurposing old enterprise gear. But I wanted to do a special selection of 3 builds, 3 configurations really, that I think are of particular interest to building a very low power and relatively low cost for what you get. I mean, there's a spectrum of cost here, to be sure, but relatively low cost for what you get home server options that will idle as low as about 10 watts of power. Yeah, and we can do that with x86. We don't have to go ARM. Okay, it's easier when you use ARM. That's kind of like cheating. But I'm assuming that you're a little bit of a performance junkie, and a Raspberry Pi or a Raspberry Pi on steroids is probably not going to cut it. In another 2 or 3 years, we probably will reduce the power usage further. But coming down from 100, 200, 300 watts of your old enterprise gear to 35, 25, 10, 5 watts, it's diminishing returns. And even when these systems are fully loaded, they're not going to use a ton of power, but I'm also going to show you how to set these up so that you can securely access them from anywhere. We're going to use Tailscale for that, and we're going to use TrueNAS Scale as our operating system. It's a Linux-based operating system, and we're going to get all that going. There's a guide in the forum, but there's a couple of things we got to talk about for what your goals are. First up is this mini ITX system that was sent by Micro Center, but it's from Supermicro. This is a 6-core Intel Xeon. It has error correcting memory, and this is the most server-ish one of the bunch, with our other system here that we'll talk about in a minute being a close second. This system is also going to be the most expensive. The 6-core processor in here is maybe overkill for your needs. You could drop down to an i3, you could drop down to a Pentium. But Intel is starting to play it a little weird and different than they used to with error correcting memory. So it's sort of strange. Alder Lake, this is what this system is. This is the ASRock DeskMeet that I reviewed separately. This is strictly speaking a desktop system based around the B660 chipset. Error correction is not an option here, but the W680 chipset from Intel will enable error correction on most Alder Lake CPUs. And that's not really anything super new because this is an older generation Xeon. This is not LGA 1700, but in this generation of Xeon, the Xeons enabled error correction, as did the i3s and the Pentiums for very low-end embedded systems. So when we were doing like Celeron J 3070 builds a long time ago, and even some i3 builds, you could actually use error correcting DDR4 on those systems as long as the system supported error correcting memory and you were using a chipset. So Intel, I think, is playing segmentation games again they should not play, except that the 12700 in the DeskMeet actually does support error correcting memory. I've also got an i3. This is a 4-core, and we're going to look at the power usage differences, but this is a 12-core for a home server, is a fire-breathing home server option, and we'll cover that. But this, as an i3, is almost as good, and unless you know that you need 12 cores, this 4-core i3 that you can find, street retails 150, but street price is like 70, 80 bucks for this i3. But this i3 doesn't support error correcting memory according to Intel Arc. Even if it did, you need the W680 chipset, and the W680 chipset is an option that Supermicro and ASRock Rack and other companies are making available in ITX form factors and in other form factors, but you pay a little bit of a price premium. I'll say right now, for your home server, for where we are with the state-of-the-art with ZFS and TrueNAS and everything else, ECC is not as critical as it once was. Yes, it's nice to know that data corruption is being introduced, but you'll know that data corruption is being introduced in other ways, and you should have other extra backups anyway. Honestly, I'm a little bit surprised why IX Systems doesn't offer a plugin in TrueNAS. If there was a one-click thing where it's like, give IX, you know, 50 bucks a month, and we will let you back up a terabyte of information, and it's push button in TrueNAS, they could make a lot of money tomorrow. All IX would have to do is look at online services like Tarsnap, which offer a reasonable service for a reasonable price, and make that basically push button in TrueNAS. Heck, if they don't want to do that, just partner with the Tarsnap people and take a commission. It's an easy button solution, and then you can replicate this thing to the cloud. Something bad happens, or you upgrade hardware, hit a button, and it comes back down. ZFS is really awesome for that. You should check out the Level 1 video where we partnered with 45 Drives to do an off-site backup. The machinery in ZFS that we did in that video is exactly the same as what we're looking at the small low-end systems here. All right, well, let's dive in configurations. Now, for the drive and storage configuration, I'm gonna use two 20 terabyte Iron Wolf Pros as our primary data storage mechanism. They're 20 terabytes, and there's two of them, and it doesn't really dramatically increase the power usage if you're using two of these hard drives and they're idle. And when I say idle, I mean that the drive is spun up, the motor is going, that takes a certain amount of energy, but the drive is not doing anything because that'll also consume a little bit of power. So we move from the 12, 13-ish watts of this system back up to about 30, just having two of those 20 terabyte drives connected to the system, but idle. Now I'm going to show you how that you can spin those drives down so that they're not using, they're basically using, you know, 1-ish watt of power instead of, you know, the difference between 12 or 13 watts and 35. When the system has been idle for a while, basically the drives will go to sleep, so it's going to use less power. But I also want to show you that at extreme maximum load, meaning that both drives are under heavy activity and the CPU is pegged, this system will still not consume over 100 watts from the wall. It's about 95 watts, give or take. Now, if we add our M.2 and our networking and some other niceties, it's probably going to go over the 100 watts at peak, but a regular normal load, even from a bunch of containers, even from, you know, indexing your media and doing that kind of thing, assuming that, you know, this is a workhorse, you can hook it up to a watt meter and it's going to be spiky to like 50 watts, 60 watts, then back down to 35 watts. And like I say, this is an older, you know, sort of generation lower power core, still very good. I mean, it's still modern, it's still in production and all that kind of stuff. But Alder Lake is going to be even faster than that, and so is our Ryzen system. I wanted to include Ryzen because these are the most power frugal per performance, per unit performance, like power per unit performance per unit power system for something like this that you want to do. And this is a relatively fire-breathing system because it's got a lot of cores. You know, we're talking about 6 cores, 12 cores right now, 4 cores in a minute, I'll show you that, and then this. Now, bigger picture, I also do love the fire-breathing older enterprise gear. For comparison, I've got a dual socket 2011 system we'll take a look at. But just so you know, that system, even with the power saving states and the C states turned on, you know, just a bare motherboard and power supply, that thing is going to idle right around 100 watts. And the performance is going to be on par, especially with something like this, like these 12 cores here versus the 16 cores of the older generation. It's not a fair fight, but we'll take a look at that a little later in the video. Now, the other half of our storage configuration, something that's going to help us keep those drives spun down longer, is NVMe. Now, you don't have to do this for your build, but I've got a couple of 1 terabyte M.2 NVMe, and we're going to use that as a metadata special device with ZFS. 1 terabyte into 20 terabytes, that's kind of a lot of space. Like, you probably don't really need that much metadata, but you can also create data sets that say, hey, if we have files below a record size threshold, like if you create a data set that has a 1 megabyte record size, which is not atypical for media, then anything that's smaller than whatever size you set, like say 256 kilobytes or 128 kilobytes, you can actually just store that on the M.2. And so the metadata device is very, very critical, so we're going to mirror it to, hence to 1 terabyte drives. But having all of your really tiny files and also where everything is on your big and relatively slow mechanical hard drives will change dramatically your experience using the system. So it'll be a much, much better end user experience. Another thing you might be thinking and worried about is 1 gigabit just isn't fast enough. The Supermicro system, 1 gigabit. The DeskMeet B660, the built-in NIC, 1 gigabit. Our ASRock system is available with 10 gig NICs, which is going to use more power to idle and blah, blah, blah. But fortunately, we have cheat codes for this. I did a whole separate video on your options for modifying these platforms. You don't have to settle for a 1 gig NIC, and it's not going to consume one of your PCIe slots. You can actually put network cards in M.2 slots, and VGA cards, and literally anything else. Next up, let's take a closer look at our Ryzen system. Our hardware configuration for the Ryzen system is very similar to the Supermicro in terms of IPMI and some other things. It's a micro ATX motherboard instead of an ITX motherboard. It gives us more PCIe connectivity. It's going to be bigger. I'm using an inexpensive, extruded aluminum frame. The Fractal Pop Air Mini ATX is also another inexpensive enclosed option that would be good for this build. I'm cheating a little bit. I'm using the Ryzen 3900 NoX. So this is a 65-ish watt TDP processor, but it's 12 cores. The Xeon that we just looked at from Supermicro is going to be a little bit faster on a per core basis. Our Alder Lake system is going to be quite a bit faster on a per core basis. But this is 12 real homogeneous cores. Linux, in true NAS scale, doesn't really care about, 8 plus 4, 8 big cores and 4 little cores versus 4 homogeneous cores. But if you were going to do VMware, this is the system I'd recommend for VMware, because the E-cores in VMware is not a thing that you want to undertake right now, unless you're feeling adventurous, in my opinion. This is also a 470, not a 570 series motherboard. If you look at this build and you say, wow, this motherboard is going to be super expensive. No, it's the X470 version, which right now is pretty attainable because I don't think it's in production anymore, and everybody's going for the 570. So this is about a $200 motherboard in the market right now, which I think is a good deal. It also supports error correcting memory. So you can run error correcting memory with your 3900, and it's basically fine. There is a little bit of an asterisk there, a little bit of a gotcha. It will silently correct single-bit errors, and it will report 2-bit errors to the operating system, but there is a more elaborate, normally in hardware, path for how error correction is handled. You would normally want the error correction to be injected into the system management unit so that you could look at the logs in the IPMI. The platform doesn't do that. The modules for doing that on AM4 and Ryzen are deliberately not there. And so if you look online, it's like, oh, can we confirm that error correction is working? Is it actually working? What's going on? Blah, blah, blah. You can have platform first error handling or operating system first error handling with error correction. This platform also has 2 M.2, PCIe slots out the wazoo, etc., etc. It's going to idle a little bit higher in terms of power utilization. Out of the box, the out-of-the-box configuration was almost 70 watts. But it didn't really move a lot from there for the base configuration. And that's before we add hard drives. So let's add some hard drives and see what difference that makes. Now in this configuration, we're already at a disadvantage because it's a micro ATX motherboard, not an ITX motherboard. It's going to use a little bit more power. The power supply is also a little bit of a factor here. Our EVGA power supply is 80 plus gold. I think the power supply in the Supermicro is also an 80 plus gold power supply, efficiency, that kind of thing. But Ryzen has another thing it has to worry about called low idle current versus typical idle current. You see, power supplies, when Ryzen first launched like 5 years ago, they used so little power when they were idle that power supplies had trouble supplying that little power. So there's a BIOS option that says typical idle current or low idle current. This configuration will work at low idle current, so I set that in the BIOS. Also remember that we're operating, even though it's a 12-core CPU, we are operating at that 65-watt TDP, which is actually, it'll use a little bit more power than that. And I've also added my mechanical hard drives. So with all of that, with 12 cores, this is using like 38, 39, 40 watts at idle when the system is idle. But when the system is fully loaded, it's more like 80 watts, 82 watts, 83 watts. So our total system power at peak, even with all 12 cores loaded, is a little bit lower, according to our kilowatt, than our Supermicro system. Now, the reality is that these numbers are so close together that it's a bit of a wash, and that's kind of what I was going for here. We could put a 6-core in here, or we could put, another 8-core in here, but the reality is that the silicon of these are better, and for practically no more money, I can get an extra 12 cores and basically be paying the same in electricity and other costs. Also, like, this thing has IPMI, which is gonna, vampire a little bit of power, the remote management, and the Supermicro does as well. So, depending on what your needs are, one or the other could be a better choice for you. Absolutely. This motherboard also doesn't have built-in 10 gig, which would put us at a further power disadvantage. That thing's gonna use like 5 watts at idle because it doesn't sleep and doesn't want to do anything. There's definitely a lot of reasons not to do an open air case. The fractal pop air is a breath of fresh air, literally. See what I did there? Because you got 5¼ inch bays, so you can add stuff in the 5¼ inch bay area. It's got room for physically mounting 2.5 inch and 3.5 inch hard drives, so you could go SATA if you don't need 20 terabytes of mechanical space. It's got 3 big fans. This thing will be completely inaudibly silent with this configuration, and our 450 watt power supply is basically overkill. Now, if you're thinking one of these things is not like the other, well, the ASRock DeskMeet is very aggressively priced for what it is. It is a shockingly good system, and unlike other NAS solutions, this is the completely standard ATX power supply. The motherboard is the most proprietary thing, but if the motherboard died, you could totally put an ITX motherboard in here, at least as a stopgap. It's got 2 M.2 slots. It only has the single Intel 1 gig NIC at the back, but we do have an X16 slot, and it has 4 DIMM slots, so you can put lots of memory in it. Like our other systems, there's some expandability here. You can run up to 128 gigabytes in this thing. Now, I know what you're thinking. Well, in the storage configuration, you talked about having 2 M.2 plus 2 mechanical hard drives. Does this motherboard support bifurcation? Can you run the X16 slot and X4, X4, X4? The answer is no, you cannot. Well, if you've only got 2 M.2, how are you gonna make this work? Our Intel 225V is available in an E-key configuration. Yes, we can put this in the Wi-Fi slot. It is a little longer than what normally will physically fit in a Wi-Fi slot, but that's okay. I've got a 3D printer. I can solve that problem with some 3D printing. Basically, the screw hole wants to be here in the middle of the board. I'm just gonna make a little plastic shim to hold this in place, and boom, 2.5 gig NIC. And I still have my 1 gig NIC, so I could use this for other more creative things. In terms of the value proposition, this is the champion. Yes, it's not going to support error correcting memory, but you should be taking steps to back up your information somewhere else, USB hard drive, something like that. ZFS will still detect the errors. It will not deal with errors as gracefully if you have memory that has gone really bad and is continuously producing ECC errors, but the reality is that most of the time ECC events are transient. You get a couple of flipped bits a year, and that's basically it. That's going to be detected in the system. It is nice. I mean, 2/3 of the time, 2/3 of the systems we looked at today have error correcting memory. This one doesn't. It is nice to have. It's a best practice. It's good, but it is not absolutely critical. The universe will not implode if you don't have error correcting memory. It's not like crossing the streams. Not a best practice, but it's basically fine. Now, with our Alder Lake system, it's more interesting than you might think. Our maximum power usage from this system is 125 watts. It's 120, that's 25 watts more than our worst case scenario, and really more like 45 watts more than, what we would expect. It is 12 cores, 4 efficiency cores, and 8 performance cores, and the 8 performance cores are no slouch. If we switch to the i3 in this system configuration, then our worst case scenario power draw is down around 95 watts, 90 watts, something like that. But it doesn't really move the needle much on our idle power consumption, which is the real interesting thing here. This system doesn't have remote management, it doesn't have IPMI. It's the same configuration, the same base configuration basically as our other systems. It doesn't have error correcting memory. It is basically an ITX motherboard. It has a standard-ish ATX power supply. At idle, it's 40 watts. It's sitting here, it's not doing anything. The mechanical hard drives are spinning. The idle power is about 40 watts. So if we really dot our I's and cross our T's with power utilization, we can get this system down to use about 18, 19, 20 watts, something like that. And that's with the mechanical hard drive spun down. Linux still awake. The system's not in a suspend state, an S3 state or anything like that. But Linux is in its most deep power saving mode, CPU governor frequency thing, if you want to call it that. And we're still going to consume about 20 watts from the wall, give or take, when the system is basically asleep. So what that means is that this system is basically on par with the 12-core 3900 NO-X system from AMD in terms of it's awake and the hard drives are spinning power usage. I notice here too that the power of the mechanical hard drive spinning is most of our power. If power saving is that important to you, maybe you should get 4 terabyte SATA SSDs. They'll have better durability and better longevity than mechanical drives anyway. Maybe that makes sense for your use case. Me, I like to have a lot of space for versions and snapshots and things, 20 terabytes. And this DeskMeet platform from ASRock will run a lot of virtual machines. It's a fire-breathing machine, basically. If you know that you don't plan to run a lot of virtual machines and that running this with 64 or 128 gigs of RAM makes sense, the i3 is a perfectly reasonable option. And like I say, this is the deal. This is the sweet spot deal. All of the other options that I showed you are going to cost a lot more and not really deliver anything significantly better except for serverish platform error correcting memory. That may be worth a premium to you. That's totally an option. For me, for the rate at which I upgrade and that kind of thing, if it were my money, this is probably what I would be spending it on. I really like the other platforms. I especially really like the DIY ASRock system as well, but I like the performance of this. I like the 8 bursty peak cores, and the lack of error correcting memory doesn't really bother me too much. You can set the BIOS on this to automatically turn on in the event of a power outage, which is the nicest feature. So if the power goes out, this will come back on automatically. Of course, it's the opposite situation if I'm doing this for somebody else. If somebody came to me and said, I want to build a home server and I want it to be as bulletproof as possible, I'm going for the Supermicro system. At the end of the day, it is a bit of a wash in terms of power usage and, you know, total operational costs over time. This one's going to be a little bit less upfront, but they're all basically going to cost close to the same amount of money to operate over a given period if you're using 2 mechanical hard drives in a mirrored configuration, so either one of them can die. That's why we're using 2 of them. Now this has taken me a little bit longer to explain and go over than I expected, so we're going to put the software configuration and the software setup with Tailscale. Like basically you can whip out your phone and you've got a secure tunnel from your phone to this thing. So you can run Nextcloud, you can run all your files, you can have your media, and it's not really open to the internet. That is a complete game changer in terms of maintenance. If you were running Plex and Nextcloud, or Emby and Nextcloud, and other different stuff, you're gonna have to sort of manage the care and feeding of all those applications, and pretty soon it's gonna be mining Bitcoin for somebody in some other country. And that's not a great situation. But with Tailscale, or any other VPN option, but we've gone over WireGuard, so now I'm gonna show you Tailscale. You can use the Tailscale client on your phone and your laptop and your desktop and your other machines, and they'll have a secure tunnel back to this. And anybody that's not on the secure tunnel can't get to it. So you're not even really opening it up to the internet, you're really only opening it up to your VPN. And that is a completely different situation in terms of security. So it's a great thing, it's really awesome. We'll cover that next time. If you're anxious, you can join Patreon and get to it, because it'll probably be on Patreon, but there's also a written guide that'll be linked below for how to do that. But yeah, this system, very fire breathing, very nice. Very happy with where we end up. Alright, I'm going to finish getting this put together so I can finish the how-to. And like I say, this is a perfectly reasonable, attainable home server option that's not going to idle at 125 watts. Our peak power usage is 125 watts, and I guarantee you this 12-core modern CPU is going to absolutely run circles around that old enterprise gear. It destroys it in performance, destroys it in power utilization, and yes, I know it's fun to run old enterprise gear. I do it too, but the needle has moved so far because of Alder Lake, and because of 3000 and 5000 series Ryzen CPUs, Epic Rome and Epic Milan, that a lot of those older enterprise platforms really aren't worth the cost of the electricity. I mean, energy costs and things like that have gone up as well. This thing can idle on the order of 20 watts, 10 watts if you really, really dot your I's and cross your T's on some of the other platforms for what you're building. If you use the consumer grade AM4 motherboard to get rid of the IPMI. You might give up your error correcting memory and some other options, and then you use a really power frugal CPU from AMD. Then you can get that 10-ish watt idle there as well. The mechanical hard drives are going to use more power than the rest of your platform. That's a completely different ballpark than what we're talking about with dual socket 2011 or dual socket 2011-3. The Skylake systems are okay if you can afford the energy and the clock speed is high, but I see on eBay like the 2.1 or 2.4 gigahertz, you know, Skylake, those are basically obsolete. You can get so much better performance out of something like this, and in a home use scenario, this is so much better than a rack mount system. This is basically silent, works a lot better, it's a lot more practical, it's a lot more affordable. So we had some comments in the other videos. It's like, okay, you're showing us your fire-breathing EPYC systems, which are also silent and amazing. But this is a little bit more affordable and reasonable, and really gives you 95% to 98% of what you get going the other route. So I'm Whittle, this is level 1. This has been more of a look at what you're getting into with your home server setup. The Core i3 with 4 P cores plus a platform like this is not going to break the bank, and you're going to be able to do a lot more with it than you could with a dedicated NAS platform. That said, a dedicated NAS platform is nice because it's security out of the box. You don't have to think about it. So depending on what your goals are, you got options. All right, I've rambled enough. I'll see you later.